Decisions, splits, and data. It might sound complicated, but trust me, decision trees are easier than you think. Welcome to day 9 of 30 days of machine learning. If you're new here, no worries. Check out the full playlist linked here and catch up anytime. And don't forget to hit that subscribe button so you won't miss what's coming next. Today, we're diving deep into decision trees, one of the most intuitive tools in machine learning. We'll break down how they work, step through their components, and see them in action. By the end of this video, you'll not only understand decision trees, but feel ready to use them confidently in your projects. Let's get started. Importing pandas for data handling, NumPy for computations, Matplotlib for plotting, and Seaborn to create visually appealing, polished data visualizations effortlessly. Loading the dataset using pandas and quickly glancing at the first few rows to understand its structure. Checking the dataset's structure with info, getting a statistical summary using Describe, and using Shape to see the total number of rows and columns. Plotting Apple's opening prices here, with days on the x-axis and price in USD on the y-axis, to visualize how the stock moves over time. Here, we're plotting Apple's highest price each day, with days on the x-axis and the price in USD on the y-axis. Now we're visualizing Apple's lowest price each day, with days on the x-axis and price in USD on the y-axis. Here we're plotting Apple's closing prices over time, with days on the x-axis and price in USD on the y-axis. Extracting the closing prices into a new variable and checking the last few entries to see how the data looks at the end of the dataset. Converting the closing prices into a data frame and then inspecting the last few rows to get a better look at how the data is structured now. We're predicting the next 100 days by shifting the close column, adding a new prediction column to see future stock values based on the current data. Here, we're preparing the feature data by dropping the prediction column and excluding the last 100 rows, setting up our dataset for training the model. Now, we're extracting the target values from the prediction column, excluding the last 100 rows, to match our feature data for training the model. We're splitting the data into training and test sets, using 80% for training and 20% for testing, ensuring the model is evaluated properly on unseen data. Here, we're initializing the decision tree regressor and training it with our feature data and target values to learn how to predict future stock prices. We're selecting the last 100 rows of the data, excluding prediction for future predictions. After converting this into an array, we're ready to input it into our trained model for forecasting future stock prices. Using the trained model, we're predicting the future stock prices based on the prepared data and printing the predicted values. We're storing the predicted values, then combining them with the actual data to create a validation set and compare the predictions against the actual outcomes. Now we're visualizing the original closing prices, the actual closing prices from our validation set, and the predicted values. This comparison helps us assess the accuracy of the model's predictions and understand how closely they match the actual stock prices over time. And that's a wrap on decision trees. We've seen how they can predict stock prices and help us understand trends. But if you think this is cool, wait until you see Random Forest in the next video. It's a game changer. Click on the screen to dive in. Gone?